Well, once again, hello everyone. Thanks for joining me today. Presentation will explore how we're going to use GeoIP system for base stabilization under both paved and unpaved surfaces. So, a little bit about myself. Been with Presto for about going on 18 years now. Prior to joining Presto, I spent 18 years as an engineering consultant, working on the different types of civil and geotechnical projects. I'm on a lot of committees. On the REMA Railroad committees, 1 and 5. ASTM, D18 soil and rock, and D35 geosynthetics. Also on the International ISO Committee 221, which covers geosynthetics. So today I'm going to try to share my insights, from both perspectives, as 18 years as a consultant and now 18 years with Presto. So today's presentation, we're going to cover a couple key points. I'm going to show you how the benefits of GeoIP soil stabilization, including can enhance the paved and unpaved roads, especially with the potential to use low quality fills, coarse sands, on-site materials. So I'm looking at reducing cross-section requirements and constructing roads over soft subgrades. So how the GeoIP system can reduce vertical pressures and sub-base movement. Also touch a little bit on a couple of interesting applications for stormwater management. As we go along in the presentation, feel free to type any questions in the chat window and I'll try to address them afterwards. So Presto collaborated with the Army Corps of Engineers, back in the late 70s to develop the GeoCell technology. And we really have remained at the forefront of the innovation ever since, whether that's with our GeoIP itself or with all of the custom designed accessories that we have. We do offer more than just a product. We will partner with you from the initial concept phase right through construction to ensure it's a successful project. We have a great worldwide distribution network, highly experienced, not only in geocells, but also other geosynthetics as well. So I really do believe we have the most knowledgeable distribution network available. Our project doesn't stop our support once the project leaves our facility. So once again, we'll work with you right through construction. We operate in 4 main categories. Today we'll be talking about load support, paved and unpaved roads. We could do slopes, different types of fill net, high flow channels. Once again, we do aggregate, topsoil, or concrete channels. We also build gravity and MSE retaining walls. We've done walls, reinforced walls up to a couple hundred feet, so pretty flexible solution. We also offer porous pavements. We have a vegetative porous pavement, GeoBlock, and GeoPave, which is an aggregate porous pavement. We also have construction mats, which we call GeoTerra for accessing sites in place of timber mats. So let's get right into it and how the GeoIP system works for paved and unpaved roads. The system has 2 main characteristics. It includes the cell diameter and the cell size. It comes in 3 different cell sizes, 20, 30, and 40 V. So you're looking at 8.5 inch nominal diameter, 10.5, and then 18 inches for nominal diameter. It comes in 5 different depths, 3, 4, 6, 8, and 12 inches. 12 inches, we do not use that for load support. Very hard to get full compaction with a 12-inch depth, so we limit it between 3 and 8 inches for load support applications. Also comes in different sizes. It comes in different lengths. So we'll work with you to have the best size in our project evaluation. So I'll talk about through the presentation, also the different section lengths. So when we provide a free project evaluation, we want to limit the waste. So we'll work with you laying out the system, provide the least amount of waste. So the ultrasonically welded seam, that really connects the cell walls, is critical to the function of a geocell. That's the welded seam inside of the factory. The stronger the seam strength, the better performance is a geosystem, period. We make our GeoIP 100% virgin HDPE, which provides the strongest wall strength. If the cell wall is too stiff, it can overstress the seams to potentially cause seam rupture. There's been some movement in the industry lately that people are adding fillers, calcium carbonates, certain alloys to basically increase the tensile strength of the cell wall. But the problem is the benefit you gain from increased tensile strength in the cell wall. You have to have the associated benefit in the seam. So if you don't have that increase of seam strength, you can actually lead to a complete rupture of those cells. So you got to be careful when people are just pushing tensile, because really they're just adding it to lower the cost of the product. Here you can see a typical GeoIP panel. It comes tri-folded here on a pallet, 8.5 foot nominal diameter, as I mentioned before, different section lengths. It ships very efficiently. Typical 53-foot truck can carry about 125,000 square feet of GEOP and our accessories. So, I mean, it does ship really effectively. The second characteristic is the infill material. There are 4 different types. We can fill it with a coarse sand. That was the original intent when we developed this technology with the Army Corps back in the 70s. It was actually called sand grid. And when we talk about sand infill, we want to make sure it's a coarse sand. So like a number 35 sieve, which is about 0.5 millimeters. We want to make sure that we don't use the beach sands or the real fine sand, stuff that doesn't drain, compacts well, but it can actually clog, and when it gets wet, it wants to flow. So make sure it's a coarse sand, and we can work with you on that through the, if you have a coarse sand locally available at a low cost. Like I said, it's an awesome infill. So also can use topsoil. We use it for vegetated roads, temporary vegetated all roads, crushed aggregates, and concrete. So it comes with a wide range of accessories. We specifically designed all of these accessories for the various applications. So they're engineered to enhance both the long-term structural integrity and the efficiency of the installation. So when we provide the free evaluation, we're going to have calculations in there. Our calculations are based specifically and exclusively on using Presto's GeoWeb and our accessories. So, and they don't really apply to any other geocell manufacturers. So just remember that if it goes to bid and someone wants to provide a low cost or lower cost solution, make sure that they provide a full evaluation based on their accessories, because we have really the strongest accessories out there, whether that's for load support applications, slopes, walls, channels. For load support applications, the main one is the AfterKey. The AfterKey is used to connect the panel side to side and end to end. It really does speed up installation. They're made from 100% plastic, so they'll last a lifetime of the project. They really do ensure that they remain securely connected and that the panel doesn't separate under any anticipated load. So, their specific engineering value, pretty much guarantees the durability over time. So you're not going to have, when we first started using GeoWeb, we actually connected the panels with metal staples, and you can imagine over time, the metal staples are going to corrode and they're going to lead to potential separation of the panels. You can see a person just here connecting the panels together with the AfterKey. Here's an up close photo of it. If you look at the top and bottom of the AfterKey, you can see these frictional barbs. This is a recent improvement a couple of years ago. We basically wanted to increase that frictional lockup between the cell wall and the AfterKey. So we have these frictional barbs, and that really does protect the connection against the 3 primary modes of mechanical junction failure. And that's shearing, splitting, and peeling. So, and we'll also evaluate the factor of safety for those connections in our project evaluations I'll show you. So it really is crucial that you get full calculations, like I said, for all of your different geocell projects, is looking at those 3 primary functions of panel connection failure, which are, like I said, are the shearing, splitting, and peeling. Just want to briefly show you a couple other ones. When we developed our AfterKeys, we really wanted to develop with 2 goals in sight. One was safety. We used to use, like I said, those metal staplers. You had generators, hoses, pneumatic staplers. So basically, there's a lot of tripping hazards out there. We also went to the contractors and asked them for feedback. They said they wanted something very safe, but also very quick, and something that's going to maximize the strength. They're not going to have to worry about any panel separation. So that's how we came up with the AfterKey. It gets rid of all those associated equipment and all those tripping hazards. It allows you to connect the panels together with safety and efficiency in mind. So just you can see, here's another one that shows metal hog rings. You can imagine the safety concerns with that. We do a lot of work with the railroads, mines, and you can just imagine the safety director seeing some of these connections. So just make sure that it's a safe connection when you're looking at different systems. So GeoWeb and our accessories, they are 100% made in the United States under a pretty stringent quality assurance and environmental control process. We do comply with all the requirements of the Build America, Buy America under the Infrastructure Investment and Job Act. So if you're interested in that, or you have a customer that has questions on that, we'd be more than happy to provide all the certifications not only for the GEOB itself, but also any type of production business. Everything we have is made in the United States. So it's manufactured from a proprietary blend of high quality virgin HDPE resin. We have proven our durability over the last 40 plus years since we've been installing GEOB. We don't, like I said, mentioned before, we don't have any fillers such as calcium carbonate, recycled materials, or polymer alloys. It's 100% HDPE. So when we test it in a lab. We add carbon black to it for any UV protection or HALs, if for color protection, if it's for walls. But testing has shown well over 100 years even before the carbon starts to degrade, and that's when it's subjected to 100% direct UV sunlight. Load support applications are always buried in the ground, so they're going to pretty much last forever. So just make sure that the GeoCells, you're looking at 100% HDPE. Here's just a typical cross section. You got a subgrade under a certain strength. We're going to usually put a woven or a non-woven geotextile down. When I talk about woven geotextiles, they're not slip tapes. They're not slip tape wovens that don't allow water to flow freely to the subgrade. Sorry, so we're going to have what I call enhanced wovens, or what we called them in the new AREMA railroad spec or the new AASHTO M288 highway spec. So they're called enhanced woven geotextiles. They allow water to freely flow. They keep the fines underneath, but they also provide reinforcement starting at about 2,800 pounds per foot. They're pretty expensive, so you really get a lot of bang for your buck. So sometimes we're going to have a sub base, and we'll determine that based on your site specific conditions, what your subgrade strength is and what the load is. We're going to have a GeoWeb panel. Once again, we'll do the size and the structure. Infill, as I mentioned, very flexible. We can use coarse sands, aggregate, topsoil, and if you want an aggregate, if you want a vegetated type surface for temporary roads, or even concrete. So depending on what application, a paved or unpaved road, if it's unpaved, usually we're going to have a 50 or about a 2-inch wear surface over the top of it, just to protect those top cell walls. So we'll make sure the evaluation that we provide to you really does support all of those loads throughout the life of the project. So this is how Geo 3D confinement really works. When you have a given vertical load, we really want to get that vertical load as horizontal as possible. So that's where we really shine with those low quality aggregates, the coarse sands, and potentially even recycled materials. We want that vertical load to activate the earth pressure, the active earth pressure inside of the loaded cell, to actually direct that vertical load horizontal, engage it with the cell wall to engage the hoop stresses, also to engage the passive earth pressure in the adjacent cells. So what that active pressure does is pushes out, the passive earth pressure pushes in to really support that load. Another good thing about GeoWeb is, we really do provide the confinement. So a lot of our projects, we'll have open graded aggregate for, say, I mentioned it before, stormwater control. But a lot of times, if you have a situation where you need to get a lot of drainage through the cross section, we can fill it with 100% or basically no fines in it, because that GeoWeb will provide that confinement. So another option is an open graded aggregate if you want a lot of drainage. Here you can see just the difference of stresses on the subgrade due to the loading. You can see the unreinforced on the left. You can see a typical load distribution, 45-degree load distribution, pretty typical. You see all your high stresses here, the red and the tan. The GeoWeb, how it really works is we call it the mattress effect. So it really spreads that load out over a much wider distribution angle. Like I said, it's called the mattress effect. So spreading it out, we're going to significantly reduce the stress reaching the subgrade. Rule of thumb, if you're looking at a GeoWeb load support, we can reduce that stress by at least 50%. Because we completely eliminate all those high stress, those red and the tan stresses. So, like I said, our rule of thumb is about 50% starting at. So, and here you can see I took this picture. This is up in Canada, up in the oil patch. You can see this is a typical project for us up there. This is a 5mm minus. It's basically a reject screening, so it's a reject material. They have a lot of this up there, but they have very little aggregates. If they have aggregates, they're extremely expensive. So what we do is we'll use this reject screenings, install it into the GeoWeb. And as I said before, I showed you that we really only need one cell to provide a heavy duty load. So, I mean, this is a fully loaded AASHTO H20 dump truck, so 16,000 pound wheel loads, 110 PSI tire pressure. So like I said, you get that active cell underneath and that passive pushing back. You can see how, how strong that is once it's filled in. And these panels are 100% HDP, so there's nothing to them until they're actually backfilled and compacted. So extremely strong. So talk a little bit about some recent research that we've done. Went to the University of Kansas under direction of Yi Han. I'm sure a lot of people have heard of Yi, seen him at conferences. He's part of the Drew Han formula for unpaved roads and for the geocells and geogrids and other geotextiles. He's been working on geocells for 20 plus years. Ben Lashinsky, Oregon State, he did complete his PhD thesis on geocells. He's also the chairman of the IGS committee right now, and he did the finite element analysis. Then Hayat from Penn State provided some smart rock technology. Here you can just see me able to use this recent technology to look at the stabilization benefits of that system. So we use some, basically loaded cell. We put earth pressure sensors in there to measure the earth pressure and the stress distribution through. We also added some smart rocks through Dr. Hung from Penn State. And what these do is just measure how the particles move through the cross section when they're under a cyclical load. So we added those smart rocks inside of the GeoWeb. You can imagine, through confinement, there's hardly not going to be, any movement at all. And we also placed them halfway between the top of the cell and between the top of the cross section. So a couple inches below and a couple inches above the top cell of the GeoWeb system. So we really want to see how or document how we can reduce the stress above. Because, over the last 40 years, we've had, many people reach out. We've never really had the ability to use these smart rocks. It's a recent, pretty much a recent technology. It's been over the last 5-6 years. So we really wanted to see how that aggregate moves. So here you can see this is how it basically moves in rotation. How that aggregate particle is going to move. So this is measuring your rotation. And then we also wanted to measure the movement, so how it moves in the XY plane. So every cyclical load we want to see not only does it rotate and does it move. And why is that important? Because when a particle moves under, unpaved or even a paved surface, when you see it stress, if it starts to move, it's going to start to break down. We see this a lot on railroads where you get the ballast breakdown and attrition and settlements. You got to go in there, do some retuning of the ballast layers and tamping. So it is pretty impressive. So this one really does illustrate the angular velocity, so how that the speed of that aggregate particle rotates. So you can see the big one is inside of the GeoWeb. You can imagine that there's going to be very little movement in the control section inside the GeoWeb panel. But this is a couple inches above the GeoWeb panel and below that surface. You can see in the control section where there's no stability. Look at there's massive amounts of basically rotation of that aggregate particle. So it's going to want to roll. It's going to want to break down over time. Once again, another slide looking at movement. So that's that slide I showed you on how basically the back and forth. Once again, in the GeoWeb panel, you can imagine no difference really between no really improvement or movement in the stabilized section. But look here in the control versus stabilized, a couple inches above, you can see once again massive movements of that particle laterally inside. But GeoWeb completely, really almost eliminates any movement in that. And why is that important? Because you're not going to get any running. So for unpaved roads, we're going to really decrease or almost eliminate that running, above the GeoWeb layer. And we can actually prove this to you in the calculation. So, pretty impressive results. We're going to really reduce the pressure reaching the sub base. That's really accomplished through, the stabilization and the prevention of both the lateral movement and the rotation of that aggregate particle. So by reducing that movement, we're really going to decrease the abrasion and attrition. So basically less or no running. So, less attrition, you're going to have a stronger and stable surface. So, really for unpaved roads, we can significantly decrease the amount of maintenance that you're doing. We have a lot of case studies out there. We've saved on big areas like reach stackers or for intermodal and port yards for aggregates, mining haul roads where we had projects that they were on say a mining haul road, almost every day with the greater maintain that roads, and we could cut that to a month or less even. So it's pretty significant reduction. So if you have any interest in that, please reach out to me and I can provide some case studies. So just on a couple on some unpaved roads, a couple examples here. This was a project that we did down in Louisiana. This was interesting because it was a value engineered solution. Burns and Mac, we do a lot of work with them, and they had this job down there where, pretty low subgrade CBRs, wet area. It's in Louisiana, so high rains. They had a project they started on. They were going to use some geogrids and about 12 inches of aggregate. They started on the project, and it was basically just too wet. The subgrade was too small or too low for the geogrids to work, and they had to pull it all out. And they came to us, and we did a value engineering solution using one of those enhanced woven geotextiles. The good thing about this value engineering solution, not only did it provide a successful installation, but we use that enhanced woven geotextile, basically to provide an extra reinforcement and the filtration to allow the water to flow freely. We used a 6-inch GeoWeb, a 30V, which is our mid-size cell. We filled it with a low quality aggregate, friction angle, sandy aggregate mix. Allowed some water to flow too, so it didn't have any pore pressure buildup. You can see GeoWeb is, as I mentioned before too, it's really flexible. It's can accommodate either inside or outside curves. You basically just over or under expand them. And just so you know, we will be on site on these projects to help the contractor. We also do a lot of Teams meetings beforehand to go through methods to help the installation process, speed it up and make it more efficient. So like I said, we'll be on site with you, whether that's one of our manufacturer's reps who is certified and trained before they go out on site, or it's gonna be someone from Presto itself. So we've been all around the world doing installs, so we'll definitely be there to support you and your contractor. So here you can just see how pretty much how easy it is. You just back the dump truck up to the edge of the GeoWeb panel. You're going to have most of the time a dozer or grader, something that with a GPS unit on it, where they just spread it out. Like I said, it goes down really fast. The good thing about here is they saved a lot of money, not only in time and something that worked, but they were able to use that low quality fill, which saved them a good deal of money. So, and here you can see the final road going in and around the corners. This one's been in for probably 5-6 years now, and they just do limited maintenance on just to get the surface up to maintain a couple inch wear surface. So, and this was an interesting project we did up in Canada. This was for a big sawmill. In the spring and summer, they had a lot of snow melt, rain, caused a lot of flooding, soft ground. You can imagine the permafrost or the frost coming on the ground created a lot of issues, a lot of drainage issues and rutting. Basically created some really unsafe conditions for the workers, but more importantly, it just wreaked havoc on the machinery. So all the machines running around that yard were getting all gunked up with mud and muck, so they had to do a lot of maintenance. So this owner had used GeoWeb successfully before, so they reached out to our distributor in Canada, and they went to the site, saw it, took some pictures, came back. We prepared but a full evaluation for them, written summary, cross sections, calculations, specs, installation support. And here you can see just, really had to come up with something not only to support those loads, but really to manage that water, manage that snow melt, and also stormwater, with the heavy rains that came into the summer, into the fall. So the engineer here called out for a really large rock. I think it was like about if I remember correctly, about a 2-inch minus. So they really wanted to get that water to flow freely underneath the GeoWeb layer. So they put down a couple, basically a non-woven or enhanced woven geotextile, built up that layer, and then put another layer of enhanced woven geotextile, and then a 6-inch GeoWeb layer on top with a couple inch, 2 to 3 inch wear surface. So, and like I said, rule of thumb for if you want to keep and want to get water to flow freely through here, you want to shoot for about 12% plus or minus a little bit for the fines content. So passing the 200 sieve, you want to be able to have that water to flow. So that, like I said, rule of thumb, 12% plus or minus a little bit. The 200 sieve really allows that to get free drainage. And then we will work with you. So if you can send us gradation curves, we'll take a look at it and tell you, in our opinion, if it'll work, number one, and if it will drain. So you can see just showing here that open graded, not open graded, but this one's about 12 14% fines. So just in filling it into the panels, once again, the enhanced woven geotextile. So once again, we'll work with you on that infill material. Here you can see the project going in, creating a smooth platform. I like to show this slide because of rolling and compaction. Most contractors, when they are installing things for load support, whether it's grids or fabrics or anything for that matter, or unreinforced, they really want to hammer it with the vibration. So for a GeoWeb system and for geocells, you do not want to really vibrate the cells, because you can actually shake them up right from the cross section. So when you're roller compacting this, basically just a light roll, no vibration is usually required. And if you are any vibration is needed, just make sure that whoever's on site is making sure that they don't, it's just a really light vibration and not a full vibration. And once again, someone from us will be on site, so we'll be able to monitor that too with you when they get started. So here's a project we did back a couple years ago. This was the customer reached out to us once because they had a failing access road, and we had some really good projects success with them. This was a 7.5 mile road. It's a secondary road into a regional facility up in Canada. Once again, spring melt, snow, frost. This road really went to neglect because they didn't maintain it. So they wanted to really improve that road because they're opening up another facility. One of the issues is that we had a really brief period of only 2 weeks to get all this 7.5 miles of road done. So, we did successfully complete it as designed during the wet season. Here you can see the roadway, before the installation began, very wet, low strength subgrade, about a CBR of 1. It did vary from almost, really 0.5 up to about 1.5. So we had the stage materials on the side of the road. This is, really helps speed up installation, so you don't have to handle materials multiple times. One thing will help you with that through the Teams meeting and on site. So we also had this fiber optic line running down one side of the road, so we really had to restrict anything going on this side of the road where the fiber optic line was. So here you can see the panels being connected with the Attra keys. Something that I would recommend for any load support application, whether it's using geotextiles with or without GeoWeb, I would really, if you're looking at long roads using woven geotextiles, more than one roll, say 15 feet, you should really evaluate the use of factory seaming them. If anyone's ever been out in the field and tried to overlap geotextiles, especially when it's an open field, very windy, for low subgrades, we use the ASTO M288 spec, requires about 3 feet of overlap on these really low subgrade CBR and less. So it's really important to make sure you have a consistent 3-foot seam overlap. But once again, when you can imagine when it's windy, 20, 30 mile winds, you're out in the middle of a farm field. If you've ever done it, you understand what I'm saying, because it just blows. It's almost impossible to get that. So yeah, really take a look at factory seaming. We can work through that with you with our distribution network and the geotextile manufacturers. So yeah, if that's something, please look at it, and we'll look at it. If it's a good option, cost-wise, it's about the same. A little bit of cost to seam it pretty much covers the cost of the overlapping the field. So it's a very, very good thing to look at for wider applications. So here you can just see the infill being stockpile. Once again, this backs up, dumps the aggregate infill. This was a low quality, you can see not a very high quality aggregate, had a lot of sands in it, a lot of coarse sands. So we don't want to use the fine sands, but this is a coarse sand aggregate mix. These were a little bit bigger than, I think this is about a 3/4 inch crush with a lot of sand in it. Here you can see just once again, we're getting that aggregate into the thing, standing it out and placing it with the bulldozer, usually with the GPS unit on it. Goes in very fast. Rule of thumb for, just placing the GeoWeb and the geotextile, you can usually get about 3,000 plus square feet an hour with 3 guys. So it goes down very fast. Some of these sites, especially on this road, once they got going and had some experience with it, they were, up 4,000 to 5,000 square feet an hour. So it goes very fast. So here you can just see the finished road. We completed it in that 2 to 3 week time span. Like I said, a good team of 3 guys can do, a couple, 3,000 to 4,000 square feet.
an hour. This was 1.3 million square feet of haul road, so we did it in less than 3 weeks. So pretty impressive. Pretty impressive. This is an interesting application. Road shoulders. I'm sure we've all driven on the highway. You can see the road shoulders, how they get eroded, how they can't support the load that they're subjected to. We do a lot of road shoulders all over the world. We can support the heavy traffic. I know I mentioned before that we can have a vegetated road surface using GeoWeb. And what we do for that, we call it an engineered fill, which is just a 2/3 mixture of like a 3/4 inch crushed and topsoil. We have a specific somewhat spec that we can work on with you, but if you're ever looking for a vegetated either temporary access road, which we do for a lot of communication towers, or even solar fields, we're going to use that 2/3 aggregate, 1/3 topsoil mix. Just mix it together and put it into the GeoWeb panel. So 2 buckets of aggregate and a bucket of topsoil, mix it up and put it in. You can see there's different ways to install it. Here he's using basically a truck to spread it out. Once it's spread out, it's going to really get most of the time you're going to hydroseed it a lot, and it's really going to provide maximum load support, but also a vegetated surface. Another thing that we do a lot is shoulders around all over on the side of highways, on the side of where the big highway trucks, like the semi trucks, cut corners. This is down in Florida at the Welcome Center on off I-75. Here, this engineer was in charge of maintaining all of these welcome centers across the state of Florida. And all the time you can see whether it's these people on vacation with their trailers going off, and they cut the corner, and you can see the significant rutting, providing no support, the semi tractors or the semi drivers, cutting the corners like that. So they want to get rid of that. So they came to us, and we worked with them to provide a solution. We put down an enhanced woven geotextile. Here we used a 6-inch web, filled it with this is in Florida, so it's pretty much a low quality granite or fill, a limestone fill, so it was a sandy limestone fill. It's a pretty cost effective for this installation, but really, that enhanced woven once keeps those clays, anything from basically migrating up and clogging that cross section. So, and here you can see extending up the road. Been in for a little over a year and haven't touched it. So if you have an aggregate, please let us know. We can help you out on that. Another thing I mentioned before is the open graded aggregate. We get a significant amount of water either stored in the GeoWeb or allowed to flow through. So we want to keep that 200 sieve to about 12, give or take a couple %. Rule of thumb, a 3/4 inch aggregate, pretty much engineered. Worldwide thinks of a 3/4 inch aggregate has about a 35% void space. So if you have a big yard, just imagine how much water you can store, inside of that. And maybe depending on your local regulations, whether it's restricting hard surface paving, you might even get credits. This is a project we did over in Europe where they weren't allowed to do any more hard surface paving. So they allowed them to take the volume, 35% of the area, and the depth of the geocell as storage, and then they basically trickle in from there. So they didn't have to, they were able to expand their parking area by getting the credit of that 35% of water storage inside the panels. So they didn't have to worry about any expanding the stormwater ponds, which they didn't have the ability to do. So it allowed them to expand their parking area. So, oops, missed a slide. So, like I said, the ability to, since we provide a confinement, we really can, like I said, confine that open graded material, even 0% fines, passing at 200 sieve. We're going to provide a lot of storage on that. Like I said, we can help you with that. We can also help you with stormwater requirements depending on your state regs. So if you have any questions, let us know, or any projects, reach out and we can take a look and see if we can help you out. So just for all of our evaluations, we're going to provide a full evaluation, regardless of side, whether it's a 500 square foot driveway or a 10 million square foot haul road. We're going to provide basically the free support. We're going to have a written summary. We're going to have calculations. We're going to show here when I'm talking about calculations. All I really need is the wheel load or type of vehicle. If you give us a ASTRA rating of a vehicle, or if it's a mine haul road, the type of cat loader that's going to go across it. From there, we get tire pressures. We'll determine the type of geotextile, whether it's an enhanced woven, a non-woven geotextile or no geotextile at all. We're going to provide that service back to you in a couple days. We'll give you the calculation. We try to aim for a minimum factor of safety of 1.4. We'll go through all of those calculations with you. So we assess the factor of safety not only for the load support itself, but we also look at the internal junctions. Those are the welded seams in the factory, and also the mechanical junctions, so the field junctions. So we check to make sure that we have adequate factor of safety, so that panels are not going to separate over time. So, make sure that if you get a calculation, it provides and checks all your internal junctions, the factors of safety, so the welded seams under load, and also the field connections, which are the etch key. And also make sure that you check your hoop stress and your hoop tension to make sure you're not overstressing the cells. So we also provide a comprehensive part of our will be a stress distribution curve. So you can see from the top of the surface going all the way down to the bottom. So say at the end of this one, you're going to have about a 45 or a 40 psi pressure underneath. Why is that important? I haven't seen them yet, but I don't know of any other geotextile or type of geotextile that can give you the stress underneath their system. We use this a lot for pipeline protection projects, whether that's for gravity sewers, stormwater, force mains, even fiber optic lines. So if you're interested or you want to limit the stress on your system, we can provide that stress underneath the GEOP system. So also on stormwater management. So if you have any stormwater cubes on site where you got to limit that, we can provide that stress distribution at the top of that surface. We can also modify the Druhan for unpaved roads. So if you have a lot of passes on the unpaved road, we'll work with you there and provide this curve. You can see between a reinforced with GeoWeb unreinforced, you're talking, basically over a foot of thickness, foot and a half of thickness. So it's pretty much significant. So like I said, if you're looking at, not only hauling in a high quality aggregate, if we can get by with a lower quality aggregate, you're gonna have a lot of cost savings in material, but also imagine the trucking, the installation time, and a lot of things lately we're looking at CO2 reduction. So if that's a part of your evaluation, let us know. We can help you with the CO2 reduction calculations also. So a lot of times we're doing projects where they don't have the money to do any kind of soil geotech report or do any field DCP tests. So I have this laminated chart. I've handed out thousands and thousands of these over the years. It's pretty much a standard chart for all our geosynthetic manufacturers, but if you have an engineer out in the field or you're out in the field, if you carry this chart, I'll send it to you if you're interested. If you're just walking across the site, say the man sinks, the person sinks over 3 inches, I can correlate that to a CBR, a shear strength, a blow count, and even a hand penetrometer reading. If you have a hand penetrometer, I can use that to convert it to CBRs and blow counts too. So if you're interested in this, like I said, a lot of projects, I'm just going to call, hey, Brian, I got a guy out in the field. He's walking across it and it sinks. He sinks about an inch or two. From that, I can go back and estimate what a CBR is, provide an evaluation, and we tweak it from there. So we don't need a full geotech report or DCPs or penetrometers. It's helpful, of course, but it's not required. So like I said, if you're interested, let me know and I can give you a copy of that chart laminated. So we'll talk about some paved surfaces. This was a cool project we were involved in. This was for the Ohio DOT. It was for a small community in Ohio. This was the main highway that goes through town. The initial project they're looking at was some geogrids and cement lime stabilization, about a 16-inch cross section. That wasn't really the issue. The issue was they couldn't have it down for the waiting time for the lime stabilization. So the local business owners, as you can imagine, being shut down for weeks on the main axis, that was not an option. So that was thrown out. So they came to us. There also was some really shallow utilities here, some shallow sewer lines and things like that. And if it got into a full replacement of those sewer and water lines, it would have been, there's no way they would have been able to complete it on time. So they came to us. We did a value engineering option. Once again, we used an enhanced woven geotextile, a 6-inch web with a local sandy aggregate mix infill. It really does maintain the stability load. It really does provide a very stable surface under any kind of paved surface, whether it's asphalt, concrete, or even roller compacted concrete. We're doing a lot of roller compacted concrete for ports, then small airfields. And then if you're looking at we're going to provide how much we can cut that cross section down. Even on some projects, we're able to cut the amount of asphalt or concrete or roller compacted concrete that you have, because we reduce that stress reaching the surface, reaching a subgrade. So from that, we can actually back calculate and help you out. You might be able to even lessen the amount of your wear surface of your paved surface. So it is very flexible. You can see in the field, you can pretty much before it's filled, it's very flexible to go on any kind of obstruction, manual covers, anything. You can cut it with a razor knife in the field. The good thing about it too is that once you infill it and you compact it, you can come right behind it and start putting the asphalt down. So you can see here, basically they stopped for the day putting the GeoWeb in. Here's the geotextile getting ready to be expanded the next day. They didn't wait. They're right on top of it with the asphalt and going to it. So there's no really delays, weather delays. We can install this stuff in rain. It's not a problem. So very flexible solution. Here's another project we did. This was an interesting project because this was a really haul road, experienced some really heavy industrial traffic, about 12, 1,500, 40 hip axle loads daily. They initially applied 4 inches of cold mix asphalt over this prepared 12 or 18-inch subgrade. And the intention was to really provide some load support, but really to reduce dust and limit the greater maintenance, because it wasn't unpaved road. But with that traffic and the heavy loads, just overwhelmed that cold mix asphalt. So once again, this owner had a lot of experience using GeoWeb and some of their unpaved roads, great success. So they reached out to us, and we had to come up with something that could meet their demands. And also we had to keep one of the lanes in. So we actually did 2 ways. We went and looked at what the existing, using the AASHTO method, what the existing roadway structural number was. So we sort of back calculated to it. So we saw that the existing roadway was built for, not even 700,000 easels, it was a little bit less than that, but we needed like 5.4 easels to meet the traffic demand. So it's significantly short. So no wonder why that roadway was failing. As you can see here, this is really just months after they put that 4 inch of cold mix down. It started to grade. There was no reinforcement. So we really had to come up with something that would provide that support for over 5 million easels, and also something to provide a stable road surface. So once again, we took the AASHTO 93 calculations, we created a structural number. Here you can see how we look at using GeoWeb, just like GeoGrids or geosynthetics. We improve the layer coefficient of those layers that we structurally support. So depending on the subgrade strength, depending on the number of easels, we're going to have a GeoWeb improvement factor, we call it. We'll work with you on that type. So we're going to enhance that structural layer here up to, say, this one was originally at 0.14, and we increased it to 0.34. So it's a significant improvement to that layer. And here's what we came up for the geo cross section. This was based on a subgrade of 3%. We put down a enhanced woven geotextile. This one had 2,800 pounds per foot of reinforcement, a 6-inch web filled with that, as I mentioned before, that 5mm rejects screenings. They had some a little bit better than that, but it was a pretty low. We covered it with here you can see a 4-inch wear surface over the top, and then a 4-inch asphalt layer. And then a 4-inch cold mix asphalt layer, but we've done a significant amount of extensions to this road over the last 6 years. I think this year we're doing a 17-mile extension again. So this has been a very successful road that hasn't had required really any maintenance. Another really important part of this road is that they had to have full access. So we had to come up with a phase plan to only refurbish half at a time. So during the day, the traffic flow was managed with flight control and diversions, but at night, the unpaved section was reopened. So like I said, it's a very flexible solution. We can drive, just basically it's an unpaved road. So at the end of the day, they fill it up with aggregate before the asphalt can be placed, and you're basically driving on an unpaved road. So this is what a portion of the road would look like after a couple of years in service. This was the first portion that we did, reduce maintenance. The frost heaves were an issue running
performing really exceptionally well in all those systems. This was interesting because the owner called us about a year after the first one went into the road. He said, everything's working great, but I have this one area where, by a bridge abutment where the asphalt's, as you can see, is failing. It's coming apart. So, can you help us out? Right at first, we thought, just like in real application, you get that high pressure at the end of a bridge abutment, that bump at the end of the bridge. So we went out there, they started digging and digging and digging, and they did not put the GeoWeb in this section. So I don't know if they ran out of it or just read the plans wrong. No one really knows. The contractor was on site. They assumed they did, but it wasn't. But here you can see, this is the only part where the GeoWeb wasn't installed. So you can see the significant benefits to how that stabilization provides any breakdowns of that cross section. This was an interesting project. It's not a road, but I like to show it because it was another value engineered solution where they wanted to use a couple layers of GeoGrid and high quality aggregate. When it went to bid, it came in significantly higher. This was out by the Seattle airport by SeaTac, and the city was not going to let all this high quality aggregate go through the downtown Seattle basically to get to the site. So they came to us. We did a value engineered solution, and we actually seen that we could use this on-site fill, so we stockpiled it and mixed it with aggregate. Once again, staging is important. We'll go through it with you. Make sure you have all the tips and tricks to put it in. As I mentioned before, those 3 guys can install about 3,000 minimum, up to 4,000 or 5,000 square feet an hour. They're installing multiple panels at a time, so it goes really fast. Here you can see this contractor wanted really specific. So this is each panel. This is 8.5 feet wide, 27 feet long. So, but you don't need to be that precise. So we'll help you with that. Once again, here you can see that stockpiled material. And you can see here they've had those survey stakes. They did this for about half the site, and then they basically stopped because, it's really pretty simple to get it. And once again, you're just dumping the fill, spreading on with a bulldozer with the GPS system, and coming back with a roller, no vibration or limited vibration, to compact it. Just an up close picture showing dumping the aggregate, that mixed aggregate onto the GeoWeb panels, and then the finished surface. Whether it's any type of flexible pavement, if it's hard surface pavement, we use the Astro method. It's a heavy duty pavement. We use the heavy duty pavement design programs. And we also use roller compacted, so the British Ports method, the Interpave method for designing heavy duty pavement. So any type of hard surface pavement you're looking at, we can help you out with that. And we'll go through the method with you, go through our improvement factors, and show you how the GeoWeb system really works. This is one of the biggest questions we always get, and the engineers, owners, is cost. How much the system costs compared to other techniques, other systems such as grids, such as fabrics. Here's just a basic comparison. As I mentioned, the same thing with designs and things. I don't recommend any standard charts or graphs. This comparison shows between a GeoCell or the GeoWeb and a couple different solutions, such as unreinforced, a grid and a geotextile part. But it really does come down to the ability of your site-specific application. So, one site you might have some local fills on site you can use. Other sites you might not. Some sites you might have sands you can use. Other sites you might not. You might have to haul in, a cheaper aggregate from a mile versus high qualities from 10 miles. So, we'll work with you on this to give you a cost. It doesn't take us that long to do it. If we're not a good solution for your project, we're going to be upfront and tell you that, a GeoWeb is not the perfect application for this site. Maybe it's a little bit overkill. We'll then work with our, our distribution network to get you a solution that, provides enough reinforcement at the most cost-effective cost. And because we really do shine in those low subgrade CBRs, say less than 3. We do a lot of work with GeoWeb in higher subgrade CBRs when you're looking at differential settlement and consolidation settlement control. But like I said, we understand we're not the solution for everything. So we'll make sure that we work with you on that. I also mentioned before with that carbon reduction, that is becoming more popular on all of our projects, especially overseas. We're looking at carbon reduction and how GeoWeb can reduce, cost, not only in materials, transportation, the manufacturing, the product and the aggregates, but, also, we're using carbon
carbon effects versus using different materials. So in summary, GeoHub is a very flexible solution. We can use all of those different infills. We can use, coarse sands, above a 35 sieve. We can, if we limit the amount of fines, say the 200 sieves to about, 12%, give or take a couple percent, we can use it as an open grade system. Allows a lot of water to flow through the system, or even on-site stormwater control and drainage. So we can potentially limit or reduce the amount of stormwater pond that you require. Also have projects where we've actually eliminated some sites where they were required to add on additional to their stormwater ponds, but we showed them that we could, keep that water inside the geocell system, in the GeoHub system, and slowly percolate it into the ground or into their existing ponds. The states let them have credits. So something else, we really do shine, like I said, on those low subgrades under CBRs, but we also can help you in heavy load situations with higher CBRs, like mine haul roads, intermodal, reach stackers with loadings up to a couple 100,000 pounds, 150 psi tire pressure. So we offer that free evaluation. It's free of charge. You go to our website at prestogeo.com and you click on the project valuation, and this form pops up. You just fill it out to the best of your abilities. You can attach, geotech reports if you have them. If you don't, I can give you that chart, or you can refer to that chart and we come up with a subgrade CBR. And from that, we can go ahead and prepare an evaluation. Once again, it's free. Once again, please don't use any standard tables or charts for any type of GeoHub solution. We prepare them for free, get back to you in a day or two. So we really would, like I said, it doesn't matter if it's, as I mentioned, 500 feet or 5 million or 10 million, we're going to give you the same support. So, we've been working off 40 years of expertise. We're going to guarantee, that each shipment meets our spec. It's 100% HDP. We have a very extensive QA QC program, EPD certifications too, if you're interested in that. And we can help you that on all of your projects. So we also made it fast and easy to obtain your PDH certs today. So with our webinar dashboard, you can usually view the library of all the webinars you download through our website. Those are the on-demand websites or webinars. We have, oh gosh, I don't know, hundreds of those on our website now. So you can go ahead and keep those, take those, keep a record of them for you, all those completed along with your PDH certs. So if you need to go in and get some, it's right there. The ones for the live webinars are managed separately from the on-demand ones. So your certificate will not be in there, but you will receive an email. Go to webinar. It should be next couple hours, 2 to 3, 4 hours, with a link to download your PDH cert. So if you don't get it, please check your spam folder because it may have gone to that. So if you don't hear from us in a couple days, just go ahead and check your spam filter, and we can help you out if you didn't receive your PDH cert. So with that, I want to thank you all for taking the time to join me today. Here's my contact information, my email, and my phone number. I got a little bit of time to answer some questions, but if something pops up in your mind later on, please reach out. Here's my email. Here's my phone number. It will help you out. It will give you free evaluations, give you a lot of support. So, as I mentioned, we're not a solution for all. We don't try to push you to, we don't have a hard push sales to get you to use GeoHub. So yeah, please let us know. And with that, I will take a look at some of the questions. Some of them here. Let me scroll up. You send a PowerPoint, Prez. This will be on our website. So give it a day or so. You can check back. It'll be on the website. Regarding the backfill, mentioned coarse sand versus fine sand. Backfill in topsoil. What's quality difference rate use payment? No, I mean the question is, can we use sand? Is there a difference related to the use of pavement for sand or other topsoil? No. So I mean, for any type of application using web, if you're looking at sand, we just want to make it about a 35 sieve or above, so about 0.5 millimeters. So that's typically what we're looking at. We're using, of course, sand. With topsoil, when you have it vegetated, we don't want to use that coarse sand. We want to use aggregate. So 2/3 aggregate, and and then 1/3 or 2/3 aggregate, 1/3 topsoil. So increased loading, what kind of factor are you looking at? I don't increase loading. Well, we can actually back calculate that. So if you have an existing structure, we can actually give you loading that it will support, but also what a GEOB solution would look like. Is GEOB used below permeable pavements? Absolutely. So we have our own permeable pavements. I think I mentioned them at the beginning, GeoBlock, which is a vegetated, and GeoPave, which is a aggregate solution. Under low subgrade soils, we will put the GEOB under them a lot. A lot of times we put under to basically contain a fully 100% open graded material, so no fines. And sometimes we'll put underneath it because it's just required because of loading. But yeah, if you have a question like that, let us know. We also do a lot on top of stormwater chambers. I mentioned in the presentation that you want to limit the stress on those stormwater chambers so they don't collapse. So a lot of these engineers are using GEOB as a stress distribution layer above the stormwater chambers. Does the quality of the aggregate affect the load capacity? No, it doesn't really affect it. We can use the higher aggregates, that's not a problem, but the lower quality of aggregate that you use has that ability to use it. So if you're looking at the low quality, 20-degree friction angles, versus the 40-degree, the high quality stuff, we can use either one. Like I said, to save money, if you have the low quality stuff, that's where you really get the bang for the buck. So Smart Rocks, simply amazing. Yeah, they really are. Those Smart Rocks are pretty cool. Someone's considering using in a walking trail. Yeah, you should reach out to me. That one, it's not really a load. It's more of we do a lot of trails with GEOB, so we can talk about the benefits of that and give you a cost. So once again, showing the presentation, yes, that'll be done. High water tables, yeah. I mean, a lot of these roads we design them to water to flow freely through it and back. So a lot of the haul roads we do up in the oil patch up in Canada, we're basically driving over muskeg, right? So in the summer, the water is just driving over a swamp. So as you access it on the truck, you'll see the water, it'll wave a little bit because it's an unpaved road, and they can do with an 1 or 2 inch wave. So you'll see the water come up when the truck is on it, and when the truck goes off, the water just flows back down into the subgrade. Now the big thing there is to use those enhanced woven geotextiles. And that's where you might design that cross section completely correct, but if you use that wrong type of geotextile, that project may fail. So yeah, please let us know, and we'll, we don't make geotextiles, but we have a lot of experience and we're very knowledgeable in them. Talking about cutting paved roads for future repairs, that's not a problem. So if you have GEOB and you want to cut it, it's no different than any geosynthetic. You just cut it. I always, most contractors, and I've been recommending this for years, is that just cut it with a PVC pipe saw. I mean, you can shake it, the GEOB, and then, or just take a PVC pipe saw and cut it, and then just scab it in another section that you cut it. So what are the limitations of GEOB? I honestly haven't seen it. We've done some haul roads, some LNG facilities over in Australia. The weight was that LNG facility was so large that just due to the weight, if it stopped for more than 5 minutes, it would sink into the subgrade and have to completely take it apart. So that was, we designed a cross section there. Albeit it was 2 meters, I think, in section with 4 layers of geotextiles, woven geotextiles, so 2 layers of web. It was extensive, but I've never seen a load higher than that. What is your take on reinforcing multiple layers for a smaller and higher load? Yeah, we're using multiple layers of GEOB. Back 20 years ago, I would say yes. Recently, with the advancements in the geotextiles, especially the enhanced wovens, they provide that extra strength at a very cost-effective rate. So a lot of times we're doing now, unless it's a really, really poor subgrade, that you need to provide a working surface, so a geotextile and a GEOB layer, and then build it up from there. A lot of times we're just using enhanced woven geotextile and increasing that strength and then building it up from there. So we really want to get those geotextiles into tension. So we want to put
a 6-inch, surface above them. So we do that on the, over top of the geotextiles. Is crushed shell a suitable fill for? Yes, we've used crushed shells before definitely on some aggregate on paved roads for sure. Well, I think I've hit my 12 o'clock time. So if I didn't get to your question, I apologize for that. Like I said, please, please contact me. Here's my email, and we're more than happy to help you out. So with that, like I said, I want to really thank you again for joining us today, and everyone have a good day. Thank you.